You know, every single day, something pretty incredible happens. Trillions of tons of water rise and fall all across our planet in this silent, powerful rhythm. We're talking about the tides, of course, but have you ever stopped to wonder what invisible force is actually strong enough to move entire oceans? Well, today we're going to dive into the cosmic tug of war that makes it all happen. I mean, if you've ever spent a day at the beach, you know this rhythm really well. You set up your towel, and then a few hours later, you realize the water is creeping up the shore, getting closer and closer. And then, just as mysteriously, it retreats back out again. This constant ebb and flow, it's like the very pulse of our oceans. It honestly feels a bit like magic, doesn't it? But the answer is pure physics. There's this immense, totally invisible force conducting this massive movement of water, twice a day, every single day. And the answer isn't here on Earth, it's way out there, in space. And that answer, in just one word, is gravity. Yep, that same silent force that governs so much of our universe. So to really understand the tides, we first have to get a handle on how this fundamental pull actually works. Okay, so let's start with the absolute basics. Gravity is never a push, it is always a pull. It's this fundamental attraction that every single object with mass has on every other object. We're talking everything from an apple falling from a tree all the way to entire galaxies clustering together across the universe. And the really crucial part here is mass. The more massive an object is, the more stuff it's made of, the stronger its gravitational pull. It's pretty straightforward, right? A huge planet is going to have a way stronger pull than a tiny little pebble. And a star's pull? Whoa, that's way, way bigger than a planet's. This simple idea is the absolute key to understanding the tides. And this force operates on a scale that is just mind-boggling. The very same gravity that's pulling our ocean tides back and forth is what's keeping the Earth in a nice, steady orbit around the sun. It's the cosmic glue holding our whole solar system together in this beautiful, delicate dance. So if everything has gravity, what's specifically causing our tides? Well, it turns out there are two main culprits in our celestial neighborhood. Let's start with the most important one, our very own moon. Because the moon is so close to us, its gravity has a really powerful tug on our planet. And that pull is strongest on the side of the Earth that's facing the moon. It pulls the water into a sort of bulge, and that's a high tide. But here's the really wild part. Another high tide also forms on the opposite side of the Earth at the same time. How? Well, the moon is basically pulling the solid Earth away from the water on that far side, which leaves that water to bulge out too. It's pretty cool when you think about it. But wait, the moon isn't working alone here. There's another, much bigger player involved in this gravitational game, the sun. Now, the sun's mass is just enormous, so its gravitational pull is incredibly powerful. But, and this is a big but, it's about 400 times farther away from us than the moon is. And that distance really weakens its effect on our tides. It's actually less than half as strong as the moon's. But when the sun's pull and the moon's pull line up and combine, well, that's when things get really interesting. And that cosmic alignment is everything. See, depending on where the sun and moon are in relation to the Earth, their gravitational forces can either team up or they can work against each other. And this creates two very distinct types of tides, spring tides and neap tides. First up, let's talk spring tides. And no, they have absolutely nothing to do with the season. The name comes from the idea of the tide springing forth. This happens whenever the Earth, the moon, and the sun are all in a straight line, which you might guess happens during new moons and full moons. So when they're all lined up like that, the sun's gravity and the moon's gravity are pulling on our oceans in the same direction. Imagine two people playing tug of war, but they're both on the same side, pulling the rope together. Their combined force creates the most extreme tides possible. And that is the absolute bottom line for spring tides. The difference between high tide and low tide is the greatest it can be. You get the highest of the high tides and the lowest of the low tides. It is the tide at its most extreme. So what happens when they're not working together? Well, that's when we get a neap tide. This happens when the moon is at a right angle to the sun from our point of view here on Earth. So think of when you see a first or third quarter moon up in the sky. All right, let's recap this whole thing. During spring tides, the forces of the sun and moon combine, creating that huge difference between high and low water. But during neap tides, the sun and moon are pulling at right angles to each other, so they partially cancel each other out. This gives us much more moderate tides, with the smallest difference between high and low. It really is a cosmic tug of war, where the alignment of our celestial neighbors decides the winner. So the next time you see the ocean's edge rising or falling, you'll know exactly what you're seeing. You're witnessing the gravitational pull of the moon and the sun from hundreds of thousands of miles away. The tides are this constant, visible reminder of these incredible unseen forces. And it kind of makes you wonder, doesn't it? What other profound effects is gravity having on our universe right under our noses?